Hi there. So we're at the start of chapter 3 in year 12 pure maths, and this chapter is called Equations and Inequalities. So what does the chapter look like? Well, it's mainly focused on simultaneous equations. Okay, you're going to see sort of some GCSE methods used here. I'll talk to you a little bit about how things are a bit different with this with A level, but we're talking about the mechanics of how you actually sort of solve the equations first, which is 3A and 3B. Next, we're going to talk about interpreting simultaneous equations, what they really mean, the link that they have to points of intersection, and some new ideas related to the discriminant, which you might have seen already if you've made some progress on chapter 2. There is a part on solving inequalities, okay, but again here we can rely quite heavily on calculator methods for part of this, which is perhaps something that's a bit different to GCSE, and then we'll talk about sketching a little bit. So solutions to equations can be any of these things. You can have a single value, so in this case, for example, x is going to be 2. We can have multiple values, so a quadratic is a good example of this, where we expect sort of up to 2 equations in this one here. Why do I say up to 2? Well, remember, you can have quadratics where you never have any roots, in which case there'd be no solution. So we can have one solution here, we can have up to 2 for a quadratic. Sometimes we talk about a range of values. So range is often a good indicator that you want to use inequalities. So 3.1, 3.11, 3.5, 100. There's lots of answers to this. As I just kind of alluded to a minute ago, this one here is a special one because although it's quadratic, we have no real solutions, we would normally say. Okay, this is reserved for further maths dealing with something like this. And we can also have, this is in fact actually an identity, this one here. You can have 3 lines sometimes. This is when any value of x solves the left and the right, and the reason for that is because they're different ways of writing the same thing. So here would be some examples. So this one here, these are linear equations. So what we might do with these, for example, is we could add them together and get 2x equals 10, get x equals 5, or we could subtract and get 2y equals 8 and get it that way. But this is a single solution. As we've just said, when we have a quadratic, so in fact the top line here, this is actually, you'll find out later, this is actually a circle, but you can kind of treat it just in the same way as a normal quadratic, where what we might do is we might take this one and we'd substitute it into the one at the top. So let me give you an example of that. You could say x equals 4 minus y. Yeah. You could sub that into this bit here, and you could solve it that way. So that's quite a common thing, in fact, to actually do at A level. If you do that, you'd get these answers, but I'll show you some examples of that in a moment. No solutions. Well, you have 2 straight lines here, but why would you get no solution? Well, if you change the top one, you would get y equals minus x plus 1. If you change the bottom one here, you would get y equals minus x plus 3. So they are actually parallel lines, aren't they? So there are no solutions to that one here. Okay, and the one underneath, again, it's sort of like a trick question, okay? If you take the top equation and you multiply everything by 2, it's the same equation. So because the lines are on top of one another, there'd be infinite solutions. So don't get too bogged down with this, but I suppose the emerging idea at the start is solutions and the number of them can present in lots of different ways. So right at the start, this is your GCSE sort of throwback really. This one here would be maybe an elimination method, or you could still substitute if you wanted to. You do have a mode on your calculator, okay, which should be called equations. And then in general, you can look for the one that says simultaneous equations, number of variables 2, and you can actually type these in at A level, okay, and solve them that way. Most of the time in practice, that's what you actually do. However, with lots of this stuff, you do need to be able to do it algebraically, because sometimes you will be asked to do it algebraically. So if that's what we were meant to do, multiplying the top one by 2, multiplying the bottom one by 3, with the goal of 6x is what I'm going for. Yeah, so I would get 6x plus 2y equals 16. On the other one, I would get 6x minus 9y equals 27. Okay, so doing this and then subtracting, for example, we still need to know how to do it. Okay, so my advice with simultaneous equations is, yes, you can lean on the calculator, and a lot of the time I'd encourage you to, because this would be a minor part of the question, but we always need to be ready to do it the algebraic way, and we are asked to do that often. The one here on the right is more difficult. So why is this more difficult? It's because of the presence of x and then also x squared. So we want to do the substitution method instead. Probably the easiest way to do this would be to make the top one an x equals and then call it something like 3 minus 2y. No, actually, that wouldn't be the easiest, would it? Because look, x appears here and here. So no, a better way of doing this would be, yeah, it'd probably be to get the y on its own. Although, again, it's not amazing. You could say 2y equals 3 minus x. And then how about this for a slightly different idea for you? How about we now do 3y equals, so you can call that 4.5, yeah, multiplied by 1.5 minus 1.5x, or fraction form. Why would you do that? Well, you could swap the 3 and the y at the same time. Okay, so how about that as a slightly different idea? Nonetheless, the method really is going to involve you sort of substituting somehow. So look, they've actually done it with the x equals on this one, which is fine, but it requires substituting 2 places. So when you're doing something like that, this is the one that we need to be especially careful on, please. The answer to this part here is not 9 plus 4y squared, okay? It has the middle part as well. So what do I mean by that? Let me just illustrate. So, you know, when you do 3 minus 2y and you're squaring it, yeah, there is a 9 and a 4y squared, sure. But there's also these two parts here. 3 times minus 2y is a minus 6y, another minus 6y, okay? So you get a minus 12y as well. Let's talk about this part here. So this is another theme that we should talk about. So factorizing and solving quadratics, again, is another one that is on your calculator, okay? Solving quadratics comes up extensively. So here you're looking for the mode that says equation. You're looking for the mode then that says polynomial. Polynomial, well, x squared or a quadratic is an example of a polynomial. So you're then looking for order or power 2. You type this in and you can get your solutions. It will take you straight to, if you do that, it will take you straight to these. Okay, so it's fine to know that, but again, you are sometimes explicitly asked to show using an algebraic method, so we need to be able to do it without a calculator as well. Right, we've got some questions here, so let's just do the worked example on the left, and then I'd encourage you to pause, try the one on the right. We'll look at a nice and neat version of the working out for both. So let's change the question. Let's change the question to solve the simultaneous equations using algebra. This is the phrase that is often used in the real exam. So x plus y equals 2, 4y squared minus x squared equals 11. So because we have x squared and this has 4y squared, the x squared is a little bit easier. So we're going to, let's label it. And for equation number 1, let's just change that one then. So I'm going to get x on its own, which means x equals 2 minus y. I'm going to sub that in underneath. Look at how I sub this in. So 4y squared minus, big bracket, squared equals 11. Okay. And then I'm going to sub in the x squared result, which is 2 minus y. So I've left the space deliberately because I'm not going to forget to do that, but I might forget the equals 11 or the other parts of this. 4y squared. Let's do this bit over here. So I'm going to put all of this in a bracket first because BidMath says I should do my indices first. We had something similar to this on the last slide. So this is going to be 4 minus 4y plus y squared equals 11. Now, this negative means that you kind of treat it like expanding with a minus 1, if you like, okay? So it means we're then going to do something like 4y squared minus 4 plus 4y minus y squared equals 11. We collect the terms. We say 3y squared plus 4y. Let's bring the 11 over. It's minus 15 equals 0. Okay, and from here we would put into brackets and we would solve. I'm going to try to do this one by inspection. Okay, so I believe on this one, I might put the problems. I don't have my calculator in front of me to verify this one, but I believe on this one we are doing a minus 5, and then I need to add a 9 to that. Is that right? Hang on a minute, let me swap that around. A minus 5, and then does this work with a plus 3? Okay, minus 5y plus 9y, that should be correct. So my final answers for the y part should be y equals minus 3, y equals, if you set this equal to 0, this bit over here, you get the 5, then you get the 3, so you get 5 over 3. Run out of space now, but the next part I would do is I would get my x values, okay? So pause the video, have a quick go at that one there on the right, and we'll look at a neat version for both of these in just a second. So these were the answers to this one here. Okay, and 5 over 3 and minus 3 were the answers for my one there. You can see my neat working out now. Okay, so these ones here, these are just in order of increasing difficulty. So pause the video, have a quick go at these ones here. We'll talk about the last two in particular. So the first one is just an elimination method. Again, if you haven't already, please do now check how to solve this on your calculator. We have two that I would say use the substitution approach. If you do not have the correct answer on this one, it's likely going to be, well, I would guess it would be because of this y squared here. So just watch out with this. This is a bit more difficult than it first looks. Because you've got the 2, you've got whatever would be substituted in if this is the way that you did it. So 9 minus x and squared. Remember, the squared comes first, the 2 comes later. This one over here, this is a good example of not getting too caught up on details that actually do not matter. So what do I mean? Well, I mean, we can do for the top equation this, yeah? And then we can just use an elimination method of adding them. So we don't need to know what k is, although we could find it out later. So we can just say that 7x, if we add it, 7x is 21, x equals 3. Okay, so don't get caught up on k. It says k is a constant. That means you just behave like it's an unknown number and treat it accordingly. Finally, the last one here, this is kind of looking ahead really. This is about a concept called the discriminant. So the question goes like this. This represents a circle, which you may or may not know already from further maths if you've done it. A circle, so it goes through 2 minus 2. This one, if you rewrite this, this says y equals x plus k. So x plus k, x plus k describes a line that has a gradient of 1 and is lifted up. So it could look something like this if it were a tangent. But the problem is it could also look not quite like that. Bit hard to do this one freehand. Okay, it could look something like this. So how do we solve a problem like this? Well, what we do is we start with the way that we normally would. So simultaneous equations means that a good first step might be to do the following. Might be to say x squared plus y squared. I'm going to think now about that as being x plus k squared, okay? X plus k squared equals k. Now, what would you normally do? Don't get obsessed with the fact that k is here. What would you normally do? Remember, k is just a number. You would get everything to one side, and then you would set it equal to 0. Now, when you do that, which happens over here, we can do something quite powerful. Now, we know that when we're solving this, we're supposed to get one pair of solutions. So you're meant to kind of just get, you're meant to just sort of get like one answer. So this is looking ahead a little bit, and this is about the discriminant, but that's a bit of a sort of a bit of a look ahead. You might remember that the quadratic formula is given by this. Yeah? And it worked like this. It said you have some value and you add or subtract this thing over here. Now, if we're only going to get a pair of solutions, it means that the bit underneath, this b squared minus 4ac, must be equal to 0. And you'll see more of this later, but why is that the case? Well, when you do a number plus 0, a number take away 0, it becomes the same number. So later on, it's called the discriminant. This is very, very powerful, but if you know something about how things interact, how many solutions there are, you can find out things about this bit underneath. So when we've got this quadratic, the idea is we call the first bit an a. The bit that goes with the x, the coefficient with the x, we call that a b. And then the part that's a constant, which is k squared minus 4, we call that c. And we can substitute this in here and we can actually find out something quite interesting, which is that there are two values of k that achieve a straight line and a circle having one pair of solutions. The one pair of solutions bit is because the line doesn't cut the circle like this. It doesn't do that. What it does instead is it cuts it once. That's why we're doing this. Okay, so don't worry if that's a bit too much right now at the start, but that's kind of where we're going with it. This is taking more of an A-level turn. So it's taking these GCSE concepts and building on them a little bit. So you've now done 3A and B, which is concerned with solving simultaneous equations for linear and for quadratics. So set them equal to each other, find your solutions, write them in pairs, and remember that we're going to do much more with this in the next part.